calcium channel. So that means that this gate is going to open and close in response to something mechanical, not voltage. Mechanical means I'm going to pull on it. I'm going to physically pull on it to open it, just like the door. Pull on it to open it, push on it to close it. You okay with that? That's what would be mechanically gated. It is also called, just coincidentally, a ryanodine receptor channel. Okay, now, ryanodine receptors, what do you think they bind? Ryanodine, right? Outside of your body, right? So when we study these channels in the lab, to name them and describe how they work, we see what they bind to, just something, what we call an exogenous chemical. What do they bind to? This binds to ryanodine. Now, ryanodine has nothing to do with this story, right? The chemical ryanodine. Nothing's going to bind to this channel, but in addition to being mechanically gated in this story, it could bind ryanodine if it were outside the body. So don't worry about it. But that's just what it is. So it's a ryanodine receptor linked to a mechanically gated calcium channel, if you will. You can say it that way. Now, since this is mechanically gated, oh, well, let's leave it at that. We'll leave the story at that for now. So that's the SO. We also have a T-tubule. Right? So here's my T-tubule coming down through here, like this, coming back up. And the T-tubule is part of, the cell membrane. So here's the sarcolemma here. And this is the T-tubule down through here. Okay, coming down in there. You okay with that? Oh man. On the T-tubule, there is another receptor here. I'll put it on here, like this. It's not linked to an ion channel though. It's a voltage-gated receptor. I'm going to call it DHP receptor. Okay, now DHP. Dihydropyridine. This is ryanodine. Oftentimes we call ryanodine receptors RYR. RY for ryanodine, R for receptor. This, we abbreviate a DHP receptor. It is, I don't want to say voltage gated because there's no gate, it's not an ion channel, but it's voltage sensitive. What I mean by that is that it has one shape at resting potential, a different shape at an action potential. Hopefully you're seeing a pattern here that we do a lot of physiology by having proteins change shape under different conditions, right? So allosteric proteins give us a lot of physiology. This is an allosteric protein, it just changes shape based upon voltage. And it sits right across the way from the mechanically gated RYR channel. You okay with that? Now since it's mechanically gated, something has to physically pull on it, right? What's going to physically pull on it? The DHP receptor. Okay, like that. Now what did I just do? I just made a physical connection between these two proteins. I have a portion, an arm if you will, of the DHP receptor attached to the gate of the RYR receptor. You okay with that? It's like a door. It's like, right, it's like I'm the DHP receptor, here's the linker, there's the RYR gate. Yeah. If I'm at minus 70, I'm pulling this way. Guess what I do when I hit plus 30? I push that way. So plus 30, gate open, minus 70, gate closed. Right? So mechanically gated, this gate was mechanically gated. I'm physically pushing and pulling. What's doing the pushing and pulling? The DHP. Why does it push and why does it pull? Because it takes different shapes under different voltages. So if there's no action potential, this is what it looks like. So where's the calcium? in the SR and not in the cytoplasm. So do you have power stroke cycling? No. You're stuck over there on the left, high energy, eager to bind, but you can't. Okay? Is that all right? Then you get an action potential. What is the action potential? It's the spike. It's that spike traveling down the membrane. Travels down the T-tubule, hits the DHP receptor. When it hits the DHP receptor changes shape. Right? And what does it do here? Pulls on the door. Opens the door. And now where's the calcium go? Out here. Is that okay? And then calcium binds to troponin, displaces tropomyosin. Myosin binds finally to actin, power stroke, muscle contraction. And as long as calcium is present, over and over and over and over and over again over there, just keep going and going and going and going and going.